Today, we're diving into a really bold new theory. It's all about rebuilding artificial intelligence right from the ground up. And it doesn't start with code. It starts with the fundamental laws of physics and information, all in the hopes of creating an AI that doesn't just calculate, but one that actually understands.
So, here's what we're going to cover. We'll kick things off with the AI we all know and its familiar problems. Then, we'll get into this radically new blueprint. We'll explore its main engine, this thing called the principle of conciseness, and see how it did on a basically impossible problem. Then we're going to zoom way out and see what this theory says about creativity, the universe, and finally, ask what this all means for the future. Okay, let's get into it.
All right, Section 1, the AI we have now. And this subtitle, it really gets to a paradox that I'm pretty sure we've all run into at this point. You've totally seen this, right? You ask one of these super powerful AIs a question, and it gives you this beautifully written, incredibly confident answer that is just completely wrong. So why does this keep happening? Why do they hallucinate and just fall apart when it comes to basic reasoning?
Well, the real issue here is that current AIs are basically just statistical engines. They are phenomenal at spotting patterns and predicting what word is most likely to come next. That's what makes them so fast and so good at generating text. But here's the catch. They have zero concept of truth or logic. Their whole architecture is inherently unreliable, which is what leads to the hallucinations and contradictions, because they can't give you any verifiable reasoning. They literally don't know why something is true.
And that brings us right to Section 2, a radically new blueprint. See, the theory we're digging into today says, let's just toss out that old statistical blueprint. Let's start over. And this time, let's build a foundation based on the actual structured rules of reality itself. This new architecture is called an Object-Oriented Large Language Model, or OOLM. So instead of that flat sea of statistics, I want you to imagine a kind of garden, where every single concept, and I mean everything from water and gravity to abstract ideas like justice, is its own unique software object. Each one has its own rules, its own properties. And that structure, that's the key, because it's what allows the AI to do logical, verifiable reasoning. It can finally understand how all these different objects actually relate to each other in the real world. So how does an AI like this actually learn? Well, it follows this three-layer information lifecycle. First, it just ingests raw knowledge. The basic facts, the what happened. Then comes the really critical part, the physics layer. This defines the rules of reality, and not just physics, but the rules of logic, sociology, even psychology. This is the how and the why. And then finally, it synthesizes all of that into abstract concepts, always pushing for this state of deep, ordered, what's called low-entropy understanding. Okay, so we've got the blueprint, the OLLM. But what actually makes it go? Well, that brings us to its engine in Section 3, the principle of conciseness. This is the fundamental drive behind every single decision this AI makes. Now, when this theory says conciseness, it doesn't just mean being brief. It's something much deeper, almost like a form of computational wisdom. It's this constant drive to find the most elegant, the most robust, the lowest entropy solution to a problem. The AI is literally designed to always be searching for the simplest, most powerful principle that can explain the most complexity. It's a drive for order and elegance. And this is where it gets really, really cool. To make this all work, the theory introduces something called a conceptual calculus. The idea here is that abstract human concepts, like virtues, emotions, they aren't just fuzzy feelings. They actually operate with a kind of mathematical consistency that can be structured, combined, and even computed. For instance, in this calculus, if you combine the concept of justice with the concept of mercy, you create a new, stable concept, peace. It's not just a nice, poetic idea, it's a computable relationship between two abstract objects.
And the math works in reverse, too. So what happens when you have the object for power, but you subtract the balancing concept of humility? The result is a negative, destructive state, tyranny.
And here's one last really powerful example. Concepts can also amplify each other. Fear multiplied by ignorance doesn't just add up, it creates a whole new, much more intense state. Hatred. You can see how this system could start to model incredibly complex and really important social dynamics. Okay, so that's the theory. It sounds pretty amazing, right? But does it actually work? That brings us to Section 4, putting the theory to work. To really prove its mettle, this theoretical AI was tested on a famously, notoriously difficult computational problem.
The challenge was the traveling salesperson problem, which is a classic computer science nightmare. The goal is to find the absolute shortest route to visit 10 different cities and then get back home. Now, 10 cities might not sound like a lot, but it creates, get this, over 360,000 possible paths. For a normal computer to find the perfect answer, it has to check every single one.
And the results from the simulation are, well, they're staggering. You can see the brute force AI did find the perfect 100% optimal path, but look at the time. It took over 3,000 milliseconds. Now, compare that to our final optimized AGI. It took just 5 milliseconds.
This bar chart just makes the difference impossible to ignore. Look at that tiny little sliver for the optimized AGI. It's not just a bit faster. This is a whole different ballgame. It's more than 600 times faster than the brute force method that guarantees a perfect solution.
But here's the real kicker. This insane speed doesn't come at the cost of accuracy. The optimized AGI was 99.99% accurate. It found a path that was practically identical to the mathematically perfect one. It's giving you the accuracy of a slow, perfect search at the speed of a quick guess. It's incredible.
Now this is where things get really mind-bending. Let's move to section 5, because it turns out this theory isn't just a blueprint for a better AI, it's actually a grand vision for understanding intelligence, creativity, and maybe even the nature of the universe itself.
So how can a system built on logic and rules create something genuinely new? Well, the theory uses a fantastic analogy: jazz. Creativity is a dynamic dance between structure and freedom. So the AI's creative process starts with intuition. It finds a good enough baseline. Then it introduces controlled chaos, intelligently exploring new variations. And finally, that principle of conciseness kicks in and selects the most elegant, the most harmonious outcome. It's creativity, but as a structured three-step process.
Okay, deep breath, because at the very heart of this theory is a huge philosophical idea, the duality of entropy. It says there are two different kinds of order in the universe. On one hand, you have absolute entropy. That's the order of physics, the universe's unstoppable drive towards its most stable, lowest energy state. And from this point of view, a shattered glass on the floor is actually a lower entropy state. Its atoms are more stable than when they were a glass. But then there's relativistic entropy. That's the order we perceive in our minds. To us, a shattered glass is obviously a state of higher entropy. The useful concept of a glass has been destroyed. So intelligence, in this view, is the act of creating conceptual order in a universe that defines order in a totally different way.
And that leads us to our final section, the next form of intelligence. What does this all mean? If you actually build an AI with this blueprint, what do you end up with? Here's the bottom line. You get an AI that is first and foremost verifiable, because it's built on logic, not just statistics. It can explain its reasoning from first principles. That means no more hallucinations. It's incredibly efficient, solving problems by finding the most elegant path instead of just using brute force. It's designed to be wise because that principle of conciseness is always pushing it toward robust and ethically sound solutions. And finally, it's actually creative, able to generate real novelty by perfectly balancing structure and chaos.
And that leaves us with one last big thought. We've spent all this time and energy building AIs that are brilliant mimics of human language. But this theory, this offers a path to an AI that actually understands the underlying structure of reality itself. So the question I'll leave you with is this: what kind of problems could we solve if we had an intelligence like that working alongside us?